All right, so now that we've talked about Pascal's triangle, we've also talked about the connection with combinations like 8 choose 5 and how those numbers show up, and we've also talked about binomial expansion. We're now ready to talk about what's called the binomial theorem. And this is what it says. It looks pretty confusing, but it is actually what we just said in that prior video. It basically means if you have a binomial and you're raising it to a power, it follows this pattern. It's always this number choose 0, and then that exponent choose 1, and then all the way down to the end, and the very last number is, if you're raising to the 8th power, the last number is going to be 8 choose 8, if hypothetically n were 8. And then what happens to the exponents? The first exponents count down. So we start at x to the nth power, then the n minus 1, and then at the very end it goes down to 0. And the y, the second thing that we're raising to the n, that goes up. So we start at y to the 0. Notice that there's no y in that first term. Then y to the first, y to the second, until at the end we arrive at y to the n. So that formula looks confusing. This is how you say it in sigma notation, but you don't really have to prove that in order to be able to expand these. So I think it'll be a lot clearer when we do an example. So we'll do the first one together. And as always, I encourage you to pause and to try the next one. There's actually 4 right here. Okay, well, obviously 3 and 4 are a little bit more complicated. So here's how we would do this. Okay, we're going to expand this out. So we know, first of all, if we're raising to the 6th power, that means there's going to be 7 terms. And let's get these numbers first. Okay, so the n in this case is going to be that number 6. So it's going to be, and by the way, this expression right here is another way of saying this number choose this number. So since we're a little bit more familiar with that, I'm going to write it like that. So you have 6 choose 0, and then there's going to be, I'm going to fill these in just a sec, plus then we have 6 choose 1. Okay, then we have plus 6 choose 2. Obviously you can see a lot of work that needs to be done on these, or it tends to get pretty lengthy, but 6 choose 3, and then we're going to have 6 choose 4, and then 6 choose 5, and then finally there's our 7th term, 6 choose 6. Okay, now let's figure out what goes inside. So right here, if we look at this formula, x is the first term, it goes x to that power, and then the powers start counting down. So in this case, our first term is a, and we start at this power, a to the 6th, and the next one will be a to the 5th, a to the 4th, a to the 3rd, and you can see it's kind of nice because it just follows a pattern. A to the 2nd, a to the 1st. The last one is a to the 0, but anything to the 0 is 1. So I'm just going to cross that out so it doesn't confuse us. We don't actually need it there. Okay, then the second term, in this case the y, does the opposite. It starts with no y's, and then it goes y to the 1st, and it keeps counting up till you get y to the power that you started out with. So we start out with a 6th power. We're going to start, in this case, our second term is not y, it's 2. So we start at 2 to the 0, which remember doesn't need to be there because that's just equal to 1. Then we go 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, and finally 2 to the 6th. And now, once we have that outline penciled in, all we need to do is, I don't mean that sarcastically, I say all we need to do. It looks like a lot, but all we need to do is just basically find out what this stuff equals. So here's what our final answer is going to be. So this number, you just put these in a calculator as we did in a prior video. 6 choose 0 equals 1. And by the way, this number also equals 1, 6 choose 6. 6 choose 1 equals 6. And so does 6 choose 5. So there's another pattern here. 6 choose 2, that equals 15. And so does 6 choose 4. And then 6 choose 3 is, let me think about that. That's going to be 20, I believe. No, not 20. Trying to do this in my head, which is not always the best idea. 6 choose 3, I mean, obviously you can plug that in a calculator. That's 6 times 5 times 4 is 120. No, I guess that is 20. Yeah, it should be. I'm just going to double check with a calculator, but I do believe it's 20. Just blanking for a moment there. Yes, it is 20. Okay, so that equals 20. And then, so now let's simplify this. So the first term is 1 times a to the 6. That's just going to be a to the 6. Our second term is 6 times that 2, which is 12, times a to the 5th. So that's going to be plus 12 a to the 5th. Our next term is going to be 15 times 2 to the 2nd, which is equal to 4. So 15 times 4 is 60. 60 times that a to the 4th. Okay, then we have our next term is going to be 20 times 2 to the 3rd, which equals 8. So 20 times 8 is 160 times that a to the 3rd. Okay, the next term is going to be 15 times 2 to the fourth is equal to 16. So 15 times 16 is 240 times a squared. And then we're almost there. Then we have 6 times 2 to the fifth is equal to 32. So 6 times 32 is 192a. And then finally we have 1 times 2 to the 6. 2 to the 6 is equal to 64, and there are no a's. So our last term is 64. So this big thing right here with 7 terms in it is actually our final answer. All right, I'm going to clear this off, and I really do encourage you to pause and give number 2 a try, because it is pretty much the exact same thing. Actually, number 2 might be slightly easier because it's only to the 4th power, which means you only have 5 terms, and there's no numbers to deal with like with the 2. So I encourage you to pause it and give it a try. All right, so number 2, again, I always like to write up here how many terms we're going to have, just so we make sure we are on the right track. And we're going to have 5 terms, and let's start to write out our pattern here. So we're going to have this number choose 0, and then I'll leave parentheses for what we need to fill in. Then 4 choose 1, and then we have 4 choose 2, and you can see you need a lot of horizontal space on these problems right here. Then finally we have 4 choose 3, and then lastly, this is good, we'll be able to fit it on one screen hopefully, 4 choose 4. All right, now let's fill this in. So our first term, a, is going to go a to the fourth, a to the third, a to the second, a to the first, a to the 0, which doesn't need to be there. I'm just putting it there so you can kind of see the continuity or the pattern. And then here, for our second term, we'll just put in negative b right there, because that's really like plus negative b. So negative b to the 0, which is 1, negative b to the first, negative b to the second, negative b to the third, and then negative b to the fourth. All right, by the way, just to note, these exponents right here should always be adding up to 4, because that's what we started with. On the previous problem, they should have been adding up to 6, so that's another check. 4 choose 0 is 1, and so is 4 choose 4. 4 choose 1 is 4. So if you're choosing 1, it's always, anything choose 1 is always that number. So a million choose 1 is a million. Okay, and then also this number and this number, the thing that adds up to 4 with it, will also equal the same thing. So you can see there's like a symmetry, 1, 4, 4, 1, just like in Pascal's triangle. And then 4 choose 2 happens to equal 6. So this first term is 1 times a to the fourth, which is a to the fourth, plus, then we have 4 times a cubed times negative b to the first, which is negative b. So this number is going to be negative 4a cubed b. Okay, b to the first. And remember, these exponents should be adding up to 4, and they do. Okay. Then the next we have 6 times a squared, and then negative b times negative b, that's another way of saying negative b squared. Negative b times negative b is positive b squared, so that's going to be positive. So you can see the signs are going to alternate between positive and negative. Here we have 4. We have a negative to the third power, so it's going to be negative 4. Then we have a to the first, b to the third. And once again, these numbers are adding up to 4. That's a good sign. And then finally we have 1 times negative b to the fourth is just positive b to the fourth. So there is our binomial expansion. All right, this video is getting kind of long, so we'll save the solutions for the other two. I'm going to put them up here so you can get a head start on it if you want to. But numbers 3 and 4, we'll do those in the next video. They're slightly harder, but still following the same pattern. So see if you can give those a try.